Hello everyone, I'm back with my next lesson. So I'm still on 11-2 and we are still learning about derivative of all trig functions. So let me show you the equations for rest of the trig functions, even though I don't know if you remember we have done sine and cosine so far. So let me show you rest of those trig functions first. Okay, we are not going to go in detail to find the proofs. We could do that, but that's just going to be time consuming. So right now, I'm just going to give you the equations right away. So we have, let me just put sine and cosine already there. So derivative of sine function, it's equal to cosine. Derivative of cosine function is negative of sine function. That's what we already know so far. So we have rest of those functions. So okay, you don't have to remember those, or you don't need to memorize those equations. You could just make a flashcard with all these derivative equations. That way it's going to be easier for you to actually apply those anytime you need those. Okay, next one is derivative of, see, I'm using school colors, huh? Derivative of tangent is secant square. Derivative of secant is secant and tangent. Okay. Next one, I have derivative of cotangent is a negative cosecant square, and derivative of cosecant is equal to cotangent and cosecant with a negative in front. So if you want to look at your book, you can actually find these equations on page number 681. There's a box, so you have all those equations in there. So pretty much today I'll just show you a few more examples on applying derivative rules. So first thing what I would talk about is, because sometimes if you see square in the original equation, so that's going to be something tricky. So this is example number 7 I'm looking at. Let's pick a different color. So let's say if I pick orange this time. Okay, example number 7. Because the way you set up equation, trust me, it makes a big difference. So let's say I have cosine square and 3x. Okay, anytime the trig function itself has square on it, so that's definitely going to be rewritten first. You have to rewrite it first. How do we rewrite square function? So basically, cosine function would stay the same, even the angle stays the same. So this square goes on this entire function. So make sure anytime you see square in the original, just rewrite it like this. And once you have that, I hope you remember from yesterday's lesson, if square goes on entire function, you gotta do chain rule first. So I would bring this over. This is cosine of 3x. Next, time to take derivative of the inside one. So cosine of something was the derivative. It's negative of sine, and the angle stays the same. The last layer is the derivative of the parentheses, which is going to be 3. At the end, put everything together. So 2, negative 1, 3 makes negative 6. So cosine of 3x and sine of 3x. That would be your final answer. So keep in mind, if the function had square on it, so you could just rewrite it. Next one, I'm not gonna show you like fully, but I'm just gonna quickly show you how to rewrite it. So like I see sine of 4x and there's a square root. So how would you rewrite it? So you know square root is technically 1/2. So I would rewrite it as 1/2, and rest is pretty much chain rule. Okay. All right. So I still have to show you how to apply, like how to do rest of those trig functions. I have one more example to show you guys. Okay, actually 2 more. So let's say I have 1 minus cosine x over sine x. because again, idea is if you know those equations, rest is pretty much plug everything in and you just have to simplify. And a lot of times there's another thing. You could even simplify the original equation first and then take the derivative. You could do that. Or you can take the derivative first and then simplify. So either or, it's fine. So like this one, I see it's a fraction. I would do quotient rule. So quotient rule starts like, I have sine. First function stays the same. Derivative of the next piece would be 1, 0. Negative cosine would be negative sine, isn't it? So I have, oh my bad. So I have negative cosine, right? If I take derivative of negative cosine, you know negative stays the same. Derivative of cosine would be negative sine, which eventually becomes positive sine x. Then I have minus. Now the top one stays the same. Derivative of the bottom one would be cosine x and sine square x. Now I'm done applying quotient rule. Rest is just simplifying. So this becomes sine square x. This I would distribute. So let's distribute. And I'm just going to distribute the negative at the same time. So it's going to be negative cosine x. And it's going to be plus cosine square x. I did two things in a step. Okay, so now finally, time to simplify. So simplify means you actually have to replace identities or use fundamental identities to substitute these functions. I hope you remember sine plus cosine square, it becomes 1. If I rewrite this, it becomes this. That's my derivative equation, which could still be simplified. So this is one big fraction. I can simplify. I can split up into 2. Okay, 1 over sine square can be simplified as cosecant square x. This one, how about if I split up like sine, and I hope this makes sense because I have sine squared, so I just put it into two different ones. So cosecant square x, cosine over sine is cotangent, and 1 over sine is cosecant. So that could be another thing. So if your answer doesn't look the same as you have on the back of the book, so it means they might have simplified fully. So you could try doing that too. So I have one more example. I thought like I should show you something with tangent and cotangent as well. Actually, I have two more. So let's say if I have y is equal to x minus tangent x. Okay, first thing, since it's adding, subtracting, there's no product rule. I'll just take the derivative of each term itself. Derivative of x is 1. Derivative of tangent. So now go back to those 4 equations, the one I showed you today. So tangent x, tangent, what's the derivative? It's secant square, so I would replace this with secant square x, and x, since the angle is just x, so there's nothing else you could do, and I would leave it like this. Again, if you feel like there's any identity that works for something like this, you could apply that. If not, leave it like that. Next one, I have x times secant x. Okay, so I see x getting multiplied by another trig function, so product rule. So it's x times, okay, derivative of this part is, it's secant x times tangent x. Okay, now plus, now the second part stays the same. Derivative of x would be 1. Now the rest is just simplifying. Is there anything you could factor out? So I see, first I would actually distribute this x. Okay, keep in mind, once you distribute this x, you can now multiply the angle. So that would just stay outside or in front of the trig function. So if you distribute, oh, there's no need actually. These two were getting multiplied. But anyways, I would still keep it like this. There's no need to distribute because it's not adding, subtracting. My bad. So this is what I have. So I see they both have secant in there. So I could factor that out. So I have x times tangent x from the first one plus 1. And yeah, and there's no identity I can substitute this for. And that would be my final answer. I'm sorry, sir, guys. I have one more example. I'm sorry. I said just two, but this is going to be, promise, this is going to be the last one. So I have 2 times cotangent square. I have pi t or x plus 2. All right. First thing, I see square in the function. It means I need to rewrite this. How would you rewrite? So that square goes with the whole function. So 2, the constant would stay outside. It's cotangent of this angle. Pi t plus 2 is the angle. And then I would put parentheses around and square would go outside. This is just simple problem, simple chain rule problem. I would bring this over. So 2 times 2 becomes 4. Now cotangent pi t plus 2 stays the same. Time to take derivative of this inside piece. Cotangent. What's the derivative of cotangent? It's negative cosecant square and the angle itself, almost there. The last layer, time to take derivative of the inside piece. Pi is a constant, so derivative of pi t would be just t. Derivative of 2 would be 0. All right, that's what I have so far. Now simplify, put it together. So 4, this is negative 1. And this t would give multiply. So I would put negative 4 t cotangent pi t plus 2 cosecant square pi t plus 2. All right, so that's my final answer. So this is pretty much all. So I hope you understand the process. If not, so please just comment. I'll just go over that. All right, so anyways, thank you for watching. Bye bye, guys. Stay safe. Bye bye.